Hello. We're talking about memory this week, and today I'm going to talk about types of memory, different kinds of memory that we have. Memory that we can distinguish by the kinds of behaviors that we see when we're studying memory. Three kinds of memory: sensory memory, short-term memory, and long-term memory. We're going to talk about each one of these and show you how we can study it. Now, this chart shows you how the multi-stage idea of memory works. We have stimuli coming into our brains from the environment, and for a very brief period of time they're stored in sensory memory, where they can be forgotten, or you can attend to them. Your selective attention puts some of that sensory information that's briefly stored in their sense organs themselves into short-term memory. We tend to attend things because of relevance of what we're doing, or because of novelty. If something novel happens, we will attend to it. Or movement. We attend to movement in our environment. When it's in short-term memory, it's held there for a brief period of time where it can be forgotten, or it can be rehearsed and remembered. And rehearsal actually means that you can now encode things into long-term memory. If it's in short-term memory, we are aware of what we're remembering. If it's in long-term memory, the retention interval can occur, and so later, if we want to remember it, we have to retrieve it from long-term memory. Or it can be forgotten again. Also, by rehearsing something, it actually maintains that information in short-term memory, as we can see. And if we retrieve something out of long-term memory, or we maintain something in short-term memory, then we can make a response with that information. We can remember it. Sensory memory, attention to short-term memory, encoding into long-term memory because of rehearsal, retrieval from long-term memory so we can produce it, we can make a response. This model was originally proposed by Atkinson and Shiffrin in 1968, and still today it has proponents of this different kinds of memory, different types of memory model. Now, if we talk about sensory memory, there are different kinds of sensory memory because we have different senses, and so we should have a memory that's devoted to that particular kind of memory. Visual memory is called iconic memory, and auditory memory is called echoic memory, and there's some debate about whether we have haptic memory and smell memory, but that's pretty good evidence that we at least have iconic memory, where information about what you're seeing in the environment is maintained for a very brief period of time in the sensory process itself. A good example of that is you ever had a sparkler in your hand at night and you write your name with the sparkler and you see the trail of the light in the spark made by the sparkler. That doesn't exist in the environment. You don't have this maintenance of the information. What you're actually looking at is your iconic memory, this visual persistence that occurs not in the environment but in the receptor on the retinas itself. Now, the one way in which, different kinds of short-term memory also, some debate about whether it actually is something called primary memory, but clearly we have a digit span. How much can we keep in mind at one time? And then more commonly used is working memory, the sort of short-term processing of information that we do. If you think about it, you're listening to me now. I'm issuing words that hopefully you understand. What do I mean by that? You have to go into your long-term memory, retrieve what those words mean, link them together. I don't know how this sentence is going to end, but it's going to make some sense, hopefully, when I do end it. You have to be able to process all that information while you're remembering the words so you can put them together and make a sentence and comprehend language. It's a very complex working memory task that is a type of short-term memory. And then we have different kinds of long-term memory. We have episodic memory, we have semantic memory, and we have procedural memory. Procedural memory we talked about in the last video. Episodic memory, semantic memory, procedural memory are different kinds of long-term memory. Now I want to talk a little bit more in detail about sensory memory. Iconic memory, we hold visual information for short period of time so we can attend to the information that's relevant for what we're doing. And then, as I said, it's often called visual persistence. It was studied by George Sperling years ago, and this is what he did to show the existence of iconic memory or sensory memory. He presented an array of letters for a very brief period of time, 50 milliseconds, very short period of time, just a blink of this array of letters. And if you ask people to, once the array is removed, to simply recall the letters, they would recall about 4 letters. But if you also associated a tone with each of those rows of the matrix, of the array, a high-pitched tone, ee, for the first row, a medium-pitched tone, eh, for the second row, and a low-pitched tone, for the bottom row, and that was presented immediately after the array was removed. It's removed, but remember, we still have visual persistence of that. And the tone then tells you which row to recall, and since it's random, which row I was going to recall, I simply multiply the number retrieved by 3, because any row could have come up, and you get a recall of about 10 letters. So because the visual array was available for you to use when the tone appeared, then I can recall many more letters than I would have if I just immediately recalled. Why? Because when you report the letters, visual persistence is decaying, and you don't have that availability to read out of sensory memory but a very brief period of time. In fact, if I delay the tone, rather than present it immediately, present it a second later, your recall goes down to what the total recall would have been out of sensory memory of 3 or 4. So the tone is presented immediately, you recall over 9 letters. If the tone is just 1 second after the array, you recall the same number of letters you would have recalled if you just reported whole report right after the array occurred. So Sperling said this is evidence for visual persistence. It's evidence for iconic memory. I think very strong evidence for that. Now, short-term memory, we said, can be distinguished between digit span and working memory. And working memory is how much can you keep in mind while you're processing information. The way that's studied is primary memory is usually studied by digit span. I call that a list of numbers, and you tell me how many, you report them back in order. For example, I say 218, and you would say 218. Everybody has a digit span of three numbers. Or if I said 6, 2, 8, 4, 3, 1, 6, 2, 9, 0, you probably can get only a very few of those, because that's a digit span which is much longer than most of us have. In fact, George Miller said, how much can we keep in mind? About 7 things plus or minus 2. Between 5 and 9 items is digit span. By the way, the digit span test is actually in most global intelligence tests to measure your digit span, or what was believed when it was developed, your short-term memory capacity. How much can you keep in mind? We know now that a better definition of short-term memory is working memory, that remembering what's in mind while processing. It's a much more active memory, which actually coincides with what we do when we use short-term memory. It's remembering while processing. You're doing something, yet you still have to keep in mind certain things. An example of how working memory operates is operation span. This is a task that's used a lot by people studying working memory. We can bring it into the laboratory and look at how it operates. And what we do is we present some arithmetic problems, little subtraction and addition and multiplication tasks, have you report the response to that, usually by saying, is the result of this arithmetic operation this number? And you can say yes or no. And then it's followed by something to remember, let's say a word or a letter. And then later, after I do several of these tasks, I'm asked to give me back the letters or the words that occurred with the arithmetic problems. So I'm remembering the words or letters while I'm actively processing the math problems. Here's an example of how it might work. 4 divided by 2 plus 1 Is that 3? And I would say, true, it is. And then it'll be followed by a letter that I have to remember. All this occurs very rapidly, by the way. Then I'm given another task. For example, 3 times 3 minus 2, is that 8? And I would push false. That's not the correct number. It should be 7. And then I'm given another letter to remember, and so on, until later I'm given a recall, and you have to tell me the letters in this case that were presented after the math problems. I'm processing information while I'm actively trying to remember, keep in mind a series of letters in this case. Operation span. The interesting thing is that working memory span predicts very complex memory and cognitive tasks. In other words, there's a correlation between working memory span and many much more complex tasks like free recall, or active explicit memory, or problem-solving ability. So many people believe that this working memory capacity, the ability to hold in mind while processing, is a fundamental element in predicting cognitive behavior. Now, long-term memory we divided into episodic memory and semantic memory. They are explicit tasks, or procedural memory, non-declarative or implicit tasks. These are the 3 kinds of memory, and there's evidence that they really operate very differently from each other. Here's a chart that sort of shows how they are different. Episodic memory is like reading out of your internal diary. It's remembering something that happened to you in the past. For example, I might say, when was the last time you rode a bicycle? Well, I went to the beach last year, and I went out riding with my grandkids on a bicycle I rented. It's asking something about an episode in my past. Retrieval is conscious, and it's based on contextual cues. To remember what was the last time I rode a bicycle, I've got to actually go back into my past and retrieve the context for which that event actually occurred. Semantic memory is world knowledge. It's things that you know. I can't go back in the past and retrieve when I developed it, like who was the first president of the United States. We can answer that as George Washington, even though we don't remember the episode in that past where we learned it. We just know it. Like, what is a bicycle? Tell me about what a bicycle is. It's a part of what we know. It's a part of our world knowledge, but we can't retrieve the context of when we learned it. Sometimes I think of that, a good metaphor, as an internal encyclopedia. It's our knowledge. We don't store things alphabetically, though. We store things conceptually in our semantic memories. It's, again, retrieved by conscious, it's declarative, but it's conceptual cues that allows us to retrieve semantic memories, not contextual cues. And procedural memory is that bike riding skill that we learned. We don't know what we learned, we just know how to do something. I like to think of that as an internal computer program. You start the program, and the algorithm works, and you ride the bicycle. It's unconscious, it's automatic, we just know it, and it's like a playback of what we did when we learned how to do that skill, like riding a bicycle. Episodic memory, conscious awareness from our past. Semantic memory, world knowledge, conscious awareness. And procedural memory, unconscious ability to do something. That's it for today. Thank you.